guys doing today? Welcome to another day, another lesson, another beautiful life to experience with Mr. R. Alright, Algebra 2. Today we'll be going over probability, just the beginning half of it. I don't want to overwhelm you guys too much because you guys do have that exam you guys have to finish by this Sunday, okay? And on top of that, you have homework you should be able to finish by tomorrow as well, alright? But yes, today we'll be going over probabilities, basically tree diagrams, things of that nature. That's what I'm trying to get into today for you guys. But yeah, before that, random fact of the day, guys. Random fact of the day, we'll be talking about the word mystery. Now, I don't know if it's the word, yeah, maybe it's like a random fact, let's go over that. Could be a definition, could be later, I use later. Alright, so random fact of the day is the word mystery. Alright, now if you guys know what the word mystery means, okay, the word mystery obviously means something that is concealed, right? We don't know, we're trying to search for it. It's a mystery. It's, oh man, that man is mysterious, right? Because we don't know much about him, right? Now, mystery breaks down into two different words, all right? Now, this all comes from the Greek language, all right? Now, in the Greek word, there's this word called mustis, all right? All right? That word actually means to be initiated. Initiated, okay? All right, and then the other word that makes up mystery is the Greek word called muo, which means to keep shut.
Man, just sit there and shut up. This ain't no democracy.
Basically, the word mystery means is once you've been initiated, you must not reveal the secret.
Not being able to speak is not the same as not speaking.
Okay, that's why this word is actually very prevalent now when it comes to ideologies or maybe even religious beliefs or whatever the case is, especially when it comes to when you guys get into college and you guys got to go through if you decide to go into the Greek life, you know, fraternities, sororities, things like that. Once you're initiated, you're supposed to keep your mouth shut when it comes to certain things inside that group. And I don't mean like negative things, right? Obviously, things that are entitled to that fraternity or to that sorority, you're not supposed to tell everybody. For example, like your hand gestures when you guys throw up your signs or whatever the case is, to let people know who you are, and your calling signs, things of that nature. You can say them out loud together as a group, but you're not supposed to teach people how to do it if they're not actually part of the sorority or the fraternity. That's the mystery. That is, once you're initiated, you keep that secret quiet. You're not supposed to tell nobody, right? And that's why when you go tell somebody, like, yo, I'm gonna tell you the secret, you're like, all right, cool, what is it, bro? Like, you don't tell nobody, right? You don't tell nobody, right? So, you know, they're initiating you into letting you know the secret. So you shouldn't let anybody know. So that's pretty cool. Random fact of the day, guys, that the word mystery breaks down into the one who was initiated, you must not reveal the secret. What you guys know about probability is this. Nothing, right? But probability, all right? Now, what you probably guys have heard about probability, you may heard it before, definitely probably have, like, yo, bro, what's the probability of me getting these brand new sneakers that are dropping on the sneakers app? You know, everybody's gonna try to get them. They only made like 50,000 pairs, and you know, there's so many millions of people who want to get them. The probability of you getting it is very small, right? Like, you heard of that. Or, you know, girls, when it comes to makeup, whatever, I don't know. Don't ask me about makeup, I don't know. I don't know, I've seen the sneakers, I'll tell you about them. I don't know if it's makeup thing. But anyway, probability, it's defined as the P of A. All right, P of A represents that the amount of possible outcomes over the amount of total outcomes. All right, there's something that you should be aware of, and it's called a sample size. It's a set of all the possible outcomes that could occur. All right, and I'll put that definition in the bottom of the screen for you guys. All right. Okay, let's keep the sample size over here. For example, let me give you guys an example of maybe flipping a coin, right? Flipping a coin. Let's say we want to flip one coin, right? Let's say we want to flip one coin. And this is a very common theme here. Like, people flip coins all the time. Like, I watch battle rap a lot, right? So when the battle rappers want to go ahead and have their battle, they flip a coin. Who goes first, right? And what's the possibilities of the outcome of you actually hitting it, right? Or getting your call, you should say, right? So if you flip a coin, how many sides of the coin is there? There's two sides, right? there's obviously head and tails, right? Now, obviously, your sample size for this is what you would write as your sample size. So let's go over here. Sample size, you would write S, all right? And then you write like this little thing here, and your sample size is here. And the only thing the sample size right here is going to be head and tails, all right? That is your sample size, all right? Now let's go with something a little more. Let's go with 2 coins, right? Let's say if we wanted 2 coins. This is the first coin with a sample size that's size 2, right? Now this one is going to be a little different. Once you flip heads, after the first flip, this is the first flip here. This is your first flip, right? Okay, it's your first flip. Okay, head and tails, right? Now you can have a second flip. Now your second flip is going to be here. Okay? Alright? Actually, I'm gonna read that better. First flip is here, head and tails, and now your second flip is here. Now what you're gonna do with the second flip, once you flip heads, we know that it's gonna look like this now. Okay, if you flip tails, it's gonna look like this. Alright? Okay? So the possibilities of a second flip could be head and heads, or head and tails. Oh, head and tails. Wasn't that like that was a Disney show. Head and tails?
Oh, hell no.
No. Hidden tails. I don't know. Or if you were to flip tails the first time, and you flip it again, it could be tails and heads, or tails and tails. So then, your sample size would look like this. It would look like this. H and H, right, for head and heads. Or it could be H and T for head and tails. Then it could be T and H, all right, for tails and head, or T and T for tails and tails. So total sample size here would be 4. That is your total sample size. All right? All right, now let's try 3. Okay, let's go with 3 coins, the third flip. Okay? Now we want to do 3 coins here. So 3 coins. Let's try 3 coins. The third flip. Alright? Now the third flip you can get head and tails, right? And from the tail side, you can also get head and tails. Now from this head side, you can get head and tails, right? And then from this tail side, you can get head and tails as well. Now the key is what you want to pay attention to, and I'll show you right here. You can get heads, and heads here, right? So that's one. You go heads. You can get heads, and heads, right? But then you can get heads, and tails. Okay, you can get heads, and tails. Okay? So heads, and heads, or you can get heads, and tails. Or you can get heads, tails, and heads, right? Or you can get head, tails, and tails, right? So you can get head, tails, head, or head, tail, and tail. Okay? Now, you're gonna go down to here. Now you can get tails, head, alright? You can get tails, head, alright? Or you can get tails, head, right? Or you can get tails, head, tails, right? Tails, head, tails, alright? And then you can get tails, heads, or tails, tails. Alright? So you're gonna get tails, heads, or tails. Okay, now, if you can see here, it's a bit light. I'm sorry, guys, the marker's a little bit light. Alright, so what you're gonna get, here is the sample size now is, you're looking at 8. You got 1, 2, 3, 4, 5, 6, 7, 8. Okay? 8 different ones. Now, if you notice, it's going to be, see you have 3 here, right? So basically, the mathematical term here is you're gonna get, your outcomes will be 2 to the 3rd power. That's why you get 8. All right. So you have there's two different examples which you use so far to help you understand just a brief, generic understanding of a sample size. All right, y'all. Based on whatever we just went over, I'm gonna go a little more into detail and explain like how you get your sample size and get the percentages and things of that nature. So when it comes to your probability, it's always measured between 0, all right, 0, all right, and then you have your probability here, and then 1, okay? Now, obviously 0 means that it's never gonna happen, right? All right, and then 1 obviously means the percentage of 100, okay? So therefore, if that's 100, this is obviously 0%, right? But 1 means that it's always going to happen. Okay? Now, let's say if I was to give you a sample size of 100 people, and let's do the school. Let's say there's 100 kids in school, and I say how many kids of those wear a blue hoodie, right? Or better yet, a Poinciana hoodie, right? And let's say out of those 100 kids, you get about 20 kids, right, that are able to wear a Poinciana hoodie, right? So your sample size would have been 100, and if you say 20 of those kids are wearing them, so it would be 20 over 100, right? And then from there, obviously 20 out of 100 is 20%, right? So you're looking at 20% of those kids are wearing Poinciana hoodies, right? That's just a very small, broad example, but let me go ahead and get my eraser and write out another problem for you guys. Let's go back to the coin example, and let's say the example says, if you have 2 coins, right, what is the probability, right, that you will land on at least 1 head, right? 1 head. Let me write a head out there for you. 1 head. Okay, that is the question they're asking, right? Now, remember how we did last time? You have heads and then you have tails here. Remember, it's a 2-coin flip, right? So then you gotta have another set. So then you get boom, boom, and then boom, boom. Okay? So then you have head here, and then tails here, and you have another heads here, and another tails here, right? So therefore, you may have heads and then heads, right? Then you may have heads and then tails. All right, and then you may have tails and heads, and then tails and tails. All right. Now the question is asking you, what is the probability that you will land on at least 1 head? So it doesn't matter how many heads you're hitting as long as it's at least 1, right? So it's greater than or equal to 1, right? At this point. Right, so you're gonna count how many heads you have as long as it's at least 1. All right, so you have 1 here, 1 here, and 1 here, and then obviously, so your possible outcomes are 3, but your total outcomes are 1, 2, 3, and 4. Okay. Now, if you do your math, 3 divided by 4, you know that's 3/4 out of 4 quarters is 75 cents. So 3/4 would be 75%. Okay, that is your answer. So there is a 75% chance, the probability there's a 75% chance that you will land on at least 1 head. All right. So it's actually, this part is really not that bad, but this is something really simple that I get you guys started on. Like I said, because you guys have your exam and stuff due on Sunday, I don't want to overbear you with too many things, because I know you have 6 of the classes as well, right? Or sorry, 5 of the classes as well you're taking on top of this. So it's something simple for you guys to start off with, and then we'll go kind of deeper next week, or starting tomorrow and then next week going forward. Question. Oh, okay. There's a question out there that it should have been in 3 successions. So it was like a question with 2 follow-up questions on it, but unfortunately the questions were randomized, so it kind of messed it up. So the original question asked, if I have a right triangle at 51 degrees, and I'm given my opposite side of 9, what is my hypotenuse, right? And then the follow-up questions besides, after those would have been, find my adjacent value, and then obviously find my missing angle. lot of you have been addressing that question, and I did address it in some of the videos as well, but that's just, again, if you watch this video, I'm hoping you watch this video, that, you know, that'll also answer your questions as well, so you don't have to reach out so much, all right? So you guys have a great day, and deuces. Not mess with you. Point Santa, we good. We good. We good. Would you like that, right? That's fine. That's fine.
What's good? Yo, dog, not astronomy, understand me attack.